Welcome, everybody. This is the webinar for an introduction to AWS Identity and Access Management. We're going to dive right in. We've got a lot of slides to get through here in a relatively short period of time. So let's get started. I think before we talk about IAM specifically, it's really important to talk about an important document called the AWS Shared Responsibility Model. And you can see I grabbed a snippet of this from the website. And essentially what the shared responsibility model does is it describes for us who's responsible for what. So you can see in this diagram here, AWS sort of at the bottom of the shared responsibility model, they are responsible for security of the cloud. So things like the global infrastructure, the core services that we're using as customers, the physical data centers and networks and things like that. As a customer, we're responsible for security in the cloud, which would mean, depending on the type of service that you're using, everything on top of those sort of core services. So a common example is, let's say you're going to run a virtual machine in AWS. You're going to run an EC2 instance. You are responsible for the security of that EC2 instance from the operating system and everything above that, including things like patching, right? We often run into situations with customers that just without this understanding, we'll ask them, well, tell us about your patching for your EC2 instances. They're like, well, we don't have to do that because we're running on AWS. Not actually the case, right? So this is a really sort of foundational concept, applies to much more than IAM, applies to the platform in general. Now, when we think about a service like IAM, just to sort of really try to make this point clear, AWS is responsible for the security of the service, IAM, right? Security of the cloud. As a customer, we are responsible for the appropriate configuration of the service, in this case, IAM. And that's really where we're going to focus today. Okay, so intro slide. Let's just jump right in. Let's talk a little bit about what exactly IAM is and why it is so important. IAM, I mentioned already, stands for Identity and Access Management. This is the solution or the service that you use to control authentication and authorization in your AWS environment. For the most part, it's free. We're going to talk a little bit about some of the components, or the one component in particular that I'm thinking about that is not free, but in general, it's a free service. And it's a global service. That means that when you create resources in IAM, those resources exist across every region in the AWS account where you've created that resource. And just a little more clarification on the authentication and authorization piece. Remember, authentication is the process that IAM will follow to verify that you are who you say you are. The term in AWS, which we'll define here in a second, is a principal. We're going to verify that the principal is in fact who they are, who they say they are. And then the authorization piece of IAM is, once we've authenticated you and we know who you are, what are you either allowed or not allowed to do? When you're trying to make a request to a service in AWS, are we going to allow that action to occur? Or are we going to deny that action? And that's what IAM is all about. We're going to discuss these main components. Sometimes you'll see some of these things referred to as entities in IAM. So we're going to talk about users, groups, roles, and policies. And then we'll talk about access keys, as well as multi-factor authentication, or MFA. All right. Before we get into the details of all these different components, though, there are just two terms. There's a lot more we could talk about here, but I want to just point out two important terms that you're going to come across quite often when you're dealing with identity and access management. So the first thing you'll see a lot is what's called a principal. A principal is simply a unique identifier for either a person or a workload, and that principal can then make requests to the resources within your account. So a couple examples of a principal would be the root user, the email and password combination that you use to create your AWS account. That's an example of a principal. A user that you create within Identity and Access Management, IAM, is another example of a principal. AWS services could be referred to as principals, and so could roles in IAM. So these are all different types of principals. Another term that you're going to come across quite often, and this would be outside of IAM as well, is the ARN. This is an Amazon resource name, and it's a unique identifier for resources that exist in AWS. So you've got principals and you've got ARNs. On this slide, I'm showing you an example of an ARN. As you get more, what's the word I'm looking for? As you dive into AWS or IAM in more detail, what you're going to do is you're going to create permissions documents, which we'll talk about later on. And one of the best practices here is really to practice least privilege. And one of the important ways to practice least privilege is when you're creating your permissions documents to include the use of ARNs. So this is a unique identifier. Okay. And if you read this left to right, we'll go through it very, very quickly so you kind of understand what this is. If you've ever worked in a Linux environment, the format of this file or the format of this string should look relatively familiar. A lot of times I kind of look at this and I think of the etc password file or the etc group file in a Linux environment, right? You've got these stanzas that are separated by colons. So it's always going to start ARN, and then the next stanza is what's called the partition. Most times it's going to be AWS, but there are other partitions that exist. Think of a partition as a group of regions. The third stanza is the service identifier. So in this case, we're looking at an EC2 resource. This could be IAM, it could be S3, right? Any of the AWS services. Working further to the right here, we have the region identifier, followed by the account ID. This is the 12-digit account ID that uniquely identifies the account that you're in. And then finally, you have the resource ID or the resource type. So in this example, I've got an EC2 instance. So reading this, I now have the unique identifier for the instance. I know which account it's in, and I know which region that this EC2 instance is running in. So this is what an ARN is. It's a unique identifier for resources in AWS, and it's going to be an important part of when you're building out those policy documents and practicing this concept of least privilege, you're going to use these. All right, so now that we've gone through those couple terms, let's have a look at the sort of foundational components or concepts in IAM. So we're going to look at the different entities that you're going to create and manage within the Identity Access Management Service. Those are users, groups, roles, policy documents, access keys, and multi-factor authentication or MFA. The first piece that we want to talk about is an IAM user. This could be a person, a human. It could be an application. And these entities, a person or an application, it has permanent access to your AWS resources, depending on the permissions, but it does have permanent access or permanent credentials. It's important to note that when you first create your AWS account, there are no IAM users in the account. You're going to have to create those yourself. We're going to talk a little bit more about sort of how to best approach this, but by default, there are no IAM users. Okay. Resources in IAM, as I mentioned, are global, okay, but they are bound to a particular AWS account. So when I create a user in my account, it is bound to a single AWS account. When we think about the user itself, whether it's a person or an application, it may actually have many different types of credentials associated to it. When you create this user, you're going to have to make the decision on what types of credentials, but the most common credentials that you're going to run into are providing a user with access to the AWS console. You're going to log into the console through the web GUI. And this would be the credential example for that would be a username and password. The other commonly seen credential associated with an IAM user would be an access key. Access keys are actually used when you want to allow a user to interact with your AWS account programmatically, and they're made up of two pieces, an access key and a secret access key. Those are the two most common types of credentials that, at least in our experience, we see associated with users in accounts. There are some other things. You can create SSH credentials, which are used for services like code commit. you can also create certificates and associate those to your users. When you create that user, you're going to have to make those decisions. How do I want this user to access my environment? Through the management console, programmatically, or a combination of both. And we're going to talk about sort of best practice and least privilege later on. But essentially for now, remember that an IAM user is either a person, a human, or an application that has one or more credentials that provide it with permanent access to your AWS environment. And one more thing here. When you create an IAM user, by default, that user has no permissions in your account. You have to assign some type of permission to that user. Now, we mentioned on the previous slide, access keys. Access keys, as I mentioned, are made up of two pieces. You have an access key and a secret access key. The way I think about it is the access key is your login and the secret access key is your password, okay? The access key piece is plain text. You can look at it, you can see it as many times as you would like after you've created your access key. The secret access key you can only see once when you first create it. Amazon does not store it. If you lose that key, then there's no way for you to recover it. Okay, so that's the first thing just to mention here. These are an example of what you'll often see referred to in AWS as a long-term credential. Okay. The thing that I just want to highlight about access keys is because they are long-term credentials, there is no built-in mechanism to force a user to rotate those access keys. We review a lot of AWS accounts, and this is probably one of the biggest issues that we see in customers' accounts that we review. Amazon has changed the process of creating users, if you're creating users through the management console, and they try to dissuade you from creating access keys, but you can override that. But the biggest challenge that we see, or one of the biggest issues we see in customers' accounts is access keys that are very old, like multiple years old. And you can imagine as the age of an access key increases, there is increased likelihood that access key is going to potentially leak out of your environment, right? And then whoever has the access key and the secret access key then has programmatic access to your AWS account. You'll notice here at the very bottom of the slide, I've sort of given you one of our best practices is start with a role first. And I'll explain what a role is in a little bit here. But really, the main takeaway here is remember that access keys are used to programmatically access your AWS environment. You should not use them unless you absolutely have to. There are lots of better ways to provide either a person or an application with access to your environment without having to create these long-term credentials in it and then manage those credentials. A group is just a way to logically organize IAM users. An example, you might create an administrator group, and then as you create your IAM users, you logically put the administrators in the appropriate group. And why is a group important? A group is important because it allows you to manage permissions at a group level rather than having to manage the permissions on every individual user in your account. Okay? So just think about a group as a way to logically organize your IAM users. Ideally, you have very few users in your account, but even if you just had a few users, you should still manage their permissions at the group level. Like IAM users, there are no IAM groups created by default. When you create that new AWS account, you're going to have to go ahead and create them. So I gave you an example. A lot of times we'll see an administrative group, right? Where you put your admins in it. Another common example of groups that we see is you could have a group called all users. And what's great about that is every time you create a user, an IAM user, you dump them into the all users IAM group, and that maybe contains all of the permissions that you want to ensure every single user in your account has, managing their own credentials and things like that. The entity within IAM that you are going to spend the majority of your time with are policy documents. Policy documents are just a JSON document that defines permissions. Inside this JSON document, you are going to define what is allowed and what is denied. It's essentially what a JSON document or a policy document does. There are multiple different types of policies within AWS. Today in this webinar, we're really focusing on just one type of policy. We're talking about identity-based policies. Identity-based policies are the JSON documents that we create and maintain within the IAM service. But to give you an example of other types of policies, there are resource-based policies. There's documents called permissions boundaries. There are service control policies, SCPs. There's a whole bunch of other policy documents that you can use within your environment to help control who has access to your environment and what actions they can perform in that environment. But for today, we're really going to concentrate on identity-based policies. And here's a little bit more about that. When we look at identity-based policies, we have two types. We have a managed policy, a managed identity-based policy, and an inline identity-based policy. So first off, what's the difference? The biggest difference between the two is a managed policy is often referred to as a standalone policy. That means when you create a managed policy or use an AWS managed policy, it has its own ARN. It has its own Amazon resource name. Okay, it's uniquely identifiable because it's got that ARN associated with it. Inline policies are different. They're not considered to be standalone policy documents. They are embedded directly into the resource. So in this example here, you could create an inline policy and embed it directly into a user, or create that inline policy and embed it directly into a group. Okay. The difference is, because an inline policy is not considered to be a standalone policy, it does not have its own ARN. If you delete the entity or the resource, let's keep it easy. You create a user and then you associate that user with an inline policy. The inline policy is embedded directly into the user. If you delete the user, the inline policy goes with it. Since a managed policy is an example of a standalone policy, if I follow that same example, you have a user and you associate a managed policy to it, whether it's an AWS managed or a customer managed policy, and then you delete the user, the managed policy continues to exist even after you delete the entity, in our case, an IAM user. So that's the main difference between managed and inline. We'll talk about some other things here in a second, but that's kind of the biggest thing. You'll also notice inside or sort of we have a further categorization within the managed policy documents. We have AWS managed and customer managed. Names are pretty self-explanatory. An AWS managed policy is created and maintained on our behalf by AWS. We can use these managed policies as a way to govern permissions within our environments, right? For users, groups, roles, whatever it might be, okay? But we don't have the ability to modify those policies, okay? We can view them, we can make a copy of them, we can use that copy as the basis for our own customer managed policy, but you can't edit an AWS managed policy. So good starting point, but not something you can modify. AWS further categorizes their managed policies into two, let's call them buckets, right? There are service-related AWS managed policies. So as an example, if you go into the management console and you pull up the AWS managed policies that are available in your account, you might see something like EC2 full access, Athena full access. Okay, so those are service-related AWS managed policies. And then Amazon also has what they call job function policies. These are policies that are related to a specific job function, like a network administrator, like somebody, I don't know what they call it. They don't call it finance. I think they just call it billing. But you can kind of see, based on job role, Amazon has created a policy that they believe is a good starting point for you if you had a network administrator or somebody involved in the finance of that account. Okay, so AWS managed, created and maintained by AWS, and then broken down into two further categories. Customer managed policies, created and maintained by us. That's essentially the difference here. One of the things that we'll talk about a little later on is this idea of least privilege. And here's one of the challenges that we often see people run into is AWS managed policies are great starting points. It doesn't necessarily mean, though, that they are really least privilege policies. What we often encourage people to do is start with that AWS managed policy rather than writing everything from scratch, but then don't forget to fine tune it for your specific requirements, right? Just because you grabbed the network, I'll just use network admin, right? The job function policy that I mentioned earlier on. Just because you start with that, maybe your particular network administrative role doesn't need access to a particular service. So what you would do, or what we would suggest that you do, is you copy the AWS managed policy, you create your own customer managed policy, and then remove the permissions that your network administrator doesn't need in your particular environment. Okay. So that is identity-based policies, managed versus inline. A couple other things here just to, one of the questions we often get is, well, how do I know what should I choose? Like a managed policy versus an inline policy. Couple benefits to think about with a managed policy. I mentioned the big one already. Remember, managed policies are standalone policies. They have their own ARNs. Okay. That means if I delete the group that it's associated to, I delete the role that it's associated to, that managed policy still exists and I can use it somewhere else. Okay. I can have a single managed policy associated with multiple entities. I could have it associated to multiple groups, whatever I need. Okay. So it's not a one-to-one relationship like the inline. It's a one-to-many relationship, depending on your requirements. The other really great thing about managed policies is they're version controlled. If you go into your IAM console and you look at either an AWS managed policy or a customer managed policy, you can dig down into it and see a version identifier. For customer managed policies, you can have up to 5 versions. Okay. If you create a 6th version of a managed policy, customer managed policy, and you're doing that through the management console, you're going to get a little pop-up that says, hey, you're creating a 6th version. You can only have 5. We're going to delete the very first version. Why is that important? Well, quite often in this process of practicing least privilege, you might go in and you might tighten up a policy that you've created, right? Based on the information that you've had, based on talking to users, things like that. You say, hey, we don't need access to this service with this action anymore. So you go into the managed policy and you remove that action. And then you get a phone call and the user says, well, this just worked a half an hour ago and it no longer works. What happened? And you can say, oops, I guess they do need this. What you can do very quickly is roll back to the previous version of your managed policy. So you could go from, I'll make it up, version 4, it's the one you just published, to version 3. You can get that user up and running very quickly again. So the versioning is really handy just as a way to quickly roll back if you make a change and it breaks something that was unexpected. So benefits of using managed policies over inline policies, they're standalone, they have version control. Those are kind of the 2 big things for me when I think about why I would want to use a managed policy. We're going to talk a little bit more about sort of policy evaluation and best practices a little later on. It's important to remember that by default, IAM denies all activities. Okay, every request is denied by default. Every request is evaluated individually by IAM before that activity is either allowed or denied. IAM will follow an evaluation, a policy evaluation logic diagram, and you can find that in the AWS IAM reference documentation, and it'll show you exactly what it does. But just remember that by default, IAM will deny everything, and you need to add statements that allow somebody or something to perform some sort of action in your AWS account. All right, so I mentioned earlier on when we were talking about IAM users that at the bottom of that slide, I said, use a role first. The way that we generally approach building out solutions for customers is start with a role first. I'll explain why. A role is similar to a user in the sense that a role will provide somebody or something with access to your AWS environment. The big difference between a role and a user, though, is that roles do not provide permanent access. Instead, they allow us to provide users, workloads, AWS services with temporary access. Okay? So what we do here is we allow somebody or something to assume a role. If they're successful in assuming that role, right? If they're allowed to assume the role, which I'll show you here in a second, then they now have the permissions that are associated with that role. So if a user provides permanent credentials in your AWS account, a role provides temporary credentials. Using a role first, why do we kind of approach it that way? It helps us improve the security because we don't have to manage all of those credentials, those permanent credentials that I mentioned earlier on with users. And the other nice thing about the credentials that are associated, or maybe not associated, but assigned, right, by a role, is they're managed through a service called the Security Token Service, STS. And what will happen on our behalf is STS will automatically revoke those credentials, those temporary credentials, after the role session period expires. So not only do you not have to manage them, they're one-time use credentials that the STS service will automatically rotate and revoke for us. So much less sort of operational overhead than what we would have on a role. So not only, or sorry, not on a role, but on a user. So it'll help us improve our security by handing out only temporary access, but it also reduces the management or operational overhead of having to manage all these individual users. Yes, you still have to manage the roles, but less to manage in general. There are also multiple types of roles that you should know about. The first is what's called a service role. So this is where a service could assume a role. Okay. So when I think about a service, I'm not talking necessarily about an AWS service, but let's say you've built some sort of serverless application or something like that. You could then say, well, this service is allowed to assume the role. There are special types of roles for applications that are running on an EC2 instance. This is a role for an EC2 application. There is a name for it. I can't remember what they call it, but you can imagine if you've got a virtual machine running in AWS, an EC2 instance, and you've put your application code on it. What you want to avoid is obviously hard coding credentials on that EC2 instance or putting the credentials in your an application config file or something like that. So instead, what you do is you associate a role to that EC2 instance. Now your application can make a request to the Security Token Service, STS, and say, hey, I need credentials. And it will assume the role, get a temporary access key, a temporary secret access key, and a few other things that then you could then use in your application. Okay, so you've got a service role, you've got a role for EC2, and there is another type of special role that you'll see in your AWS account. It's called an AWS Service Linked Role. And this is a role that is created most times, right? There's always exceptions in AWS, but most times the service linked roles will be created automatically on your behalf by an AWS service that you're going to deploy, okay? The service link role essentially is going to give that particular AWS service the access that it needs to talk to other AWS services in your account. In general, you could view the service linked role, but you can't change it. There's some exceptions to that, okay? But those are the different types of roles that you might run into in your AWS environment. Most times what we're seeing are based on what customers are doing, like service roles where we're allowing maybe a Lambda function or something to assume that role as a part of a serverless application, or if we're helping customers with applications that are running on EC2 instances, then that sort of EC2 based role where the application is able to assume that role. The one thing I forgot to mention, I mentioned that there are no users, there are no groups in your account by default. There are no customer managed policies in your account by default, but there will be lots and lots of AWS managed policies, even in a brand new account. Roles are the same, Okay, depending on the services that you turn on in your account, whether that account is a standalone account or part of a larger AWS organization implementation, you may have some roles in your account when you first get started. They're typically service-linked roles or things coming from like AWS organizations or something like that. Okay, but you won't have any roles that AWS hasn't created on your behalf for the proper operation of your account. This diagram is just meant to kind of illustrate the different components that are required for a role. If we look sort of on the left-hand side of this, we have examples of principals. Right? Remember, we mentioned a principal could be a user, could be an application, could be another AWS service. These principals are assuming a role in your account to be able to do something. Okay. We think about, if we talked about earlier on in the IAM service sort of intro, we said IAM provides us with authentication and authorization. A role is kind of like that. The first thing is the authentication process. Who or what is allowed to assume this role? In this example here, when you create a role, you define what's called a trust policy. The way I think about it is the trust policy is the authentication part or the authentication mechanism for your role. Who or what is able to assume this role, right? Alice, a human, could assume this role. A particular AWS service, Lambda, could assume this role. Or maybe you've got an application, right, running on an EC2 instance. So the EC2 service can assume this role. The trust policy allows us to define which principal or principals are allowed to assume the role. So that's why I think about that as sort of the authentication part of this. And then an IAM role still needs a permissions document associated to it. This is no different than the policy documents that we talked about earlier on. Once somebody or something has assumed this role, what permissions do we want to give them through or via that role assumption? I'm showing here just a single policy permission or a policy document associated to this role, but you could actually have multiples if you would like, sort of depending on how you want to tackle it. Okay. On the left, principals, who or what is able to assume this role is controlled through the trust policy. Once a principal has been authenticated and they successfully assume that role, then what permissions are they granted through that role assumption? This is how a role works. Trying to get the slide to go forward. There we go. Okay. We haven't talked about this up to this point, but we also have the use of multi-factor authentication devices, MFA. The first thing to note is that AWS supports multiple different types of MFA devices. Virtual tokens, okay, maybe something you've got on your phone. Maybe you've got virtual tokens in a password vault or something like that. They also support hardware-based tokens, the key fob style tokens that have been around for a long time, the credit card style tokens. And then you could also, I guess it's considered, I think of it as a hardware device, but like a YubiKey or something like that. The other thing to keep in mind is that you'll often have multiple, or you might consider associating multiple MFA devices with a single user. Okay? In my example, right, I do have an IAM user in one of our accounts. MFA is associated with that user. I actually have two different MFA devices associated with that user. I have a virtual token that is stored in the password vault solution that we use. And then I have a physical token. I have a YubiKey in the side of my laptop. Why might you want two different tokens or two different MFA devices associated with your account? Well, here's an example. Let's say for some reason you can't get into your password vault, or you decided to use a virtual token on your phone and you lose your phone, or your phone breaks, or the battery's dead, something like that. You don't have that access to that token. So now I've got my backup token. I could use either or. I've got the token in the side of my laptop, right? My YubiKey. It's a great way just to have multiple options to get into your account if you needed to. So that's what MFA is. So those are the core concepts that you need to understand when you're thinking about uh, building out or configuring your IAM environment. You've got users, groups, roles, policy documents, and then we talked about two, I think, important things that I would consider core features: access keys and MFA devices. Right? I want to talk about a couple other important features of IAM that we use all the time. The first is IAM Access Analyzer. When IAM Access Analyzer first came out, it was a single component. What it did was, once it was enabled, you were able to understand which resources in your account had the ability to be accessed from external parties, an S3 bucket, let's say, as an example. Okay. That was called an external access analyzer. That was, as far as I know, that was the only feature that the IAM Access Analyzer first came out with. Since then, Amazon has introduced a number of other features that are part of the IAM Access Analyzer solution that are really, really important. Okay, so there's the External Access Analyzer. The External Access Analyzer is free of charge. Okay. A newer feature that they've introduced, I think just at reInvent last year, is what they call an unused access analyzer. And what this does is it goes out and it looks at permissions in your account. Roles, users, I think it's just roles and users right now, that haven't been used in a certain period of time. Okay, I think it defaults to 90 days, but I think you can change that. And what it does is it highlights all of those resources that exist in your account that haven't been used. Okay. Unlike the External Access Analyzer, the Unused Access Analyzer is not free. Okay, you pay for every resource that it identifies as unused in your account. Actually, I think you pay for every resource it analyzes. Be careful, understand the pricing model there. And it isn't necessarily the most affordable solution that I've ever come across in AWS, but it does exactly what it says. It's going to analyze your accounts and it's going to identify those resources that have not been used in a long period of time. Just to highlight, it does not highlight service-linked roles. Okay, those are those special roles that are created on our behalf, but everything else it will. So those are the first two main pieces. Before we move on, let me just highlight one other thing that I forgot with the External Access Analyzer piece. And I mentioned that this is how we can help determine who or what has access from outside or external access to resources within our account. How you implement that External Access Analyzer sort of depends on your account structure. You define what's called a zone of trust. So anything from outside of your zone of trust that has access to something inside that zone of trust would then be highlighted as what's called a finding, okay, in the External Access Analyzer. There are two different ways to define your zone of trust. You can set your zone of trust as a single AWS account, or if you run a multi-account deployment and you have AWS organizations set up to help you manage all of those accounts, you can set your zone of trust to the organization. So then what we're saying is anything outside of the organization would be considered external. But if you go with the single account deployment, anything outside of that account is considered to be external. And it would flag those access, it would flag those resources that are allowing access from outside of whatever you've defined as your zone of trust. Okay, so just clarify a little bit there. The other couple features that you should know about with Access Analyzer, it has policy validation. It does simple grammar checking on your policy documents to make sure they're valid, but it also will highlight for you AWS best practice. So it might highlight something saying, that's not necessarily the way you should write this policy. Maybe it's a little too wide open. It'll highlight some things for you. The nice part about this is it's a great way to help you practice least privilege, help you ensure that you're following best practice, right? So that's good. In addition to sort of those built-in AWS best practices, you can also build out your own custom policy checks to validate those documents against your particular requirements. And you also have the ability to generate or use the IAM Access Analyzer service to help you generate least privilege policies. What you can do is you can say, what's a good example? We'll say this. We'll say, I have an IAM role. I want you to analyze the permissions document associated with this role. And what it does is behind the scenes, it's going through CloudTrail. If you're not familiar, CloudTrail is a really important service. And what CloudTrail does is it records all of the API activity that's happening in your account. So what's happening is with the IAM Access Analyzer and the policy generation, you then tell it, I want you to look in CloudTrail for this role over a certain number of days. And there's a time range. I can't remember it off the top of my head. And it will go and it will look at what, in my example, what API calls that role is actually doing or actually executing. Which API calls the user that you've associated to that, or the permissions document that you've associated to, what API calls is it making? And it will go through and generate a policy for you. It's a great way to practice least privilege and over time kind of evaluate the policy documents that you've created, the permissions documents that you've created, and make sure they're still appropriate for your users. So IAM Access Analyzer is one of those things that's really easy to overlook. You need to understand the cost model of it, the pricing structure, especially if you're interested in the unused Access Analyzer piece, because it's not cheap. But at a bare minimum, what I would suggest is you enable the external Access Analyzer, define your zone of trust, single account, or your entire organization, and then start taking action on those findings. One last thing about the Access Analyzer before we move on. It generates findings. And you might start looking through those findings and say, yeah, it's perfectly okay that external access is happening from X to a service in my account. That's fine. I know what that is. You can generate rules. You can create rules that will auto archive those findings based on your particular rules. So it can just filter out those kinds of things that you would expect to see. And then you could worry about the things that you didn't expect to see. Okay, so that's Access Analyzer. And this seems really obvious, but as I mentioned, we review a lot of AWS accounts, and I would say the vast majority of them do not have a password policy. Password policy, just like it says here, it's a really simple way for us to ensure that we are helping our users practice good password hygiene, right? We want to make sure a password is a certain length. It has certain types of characters in it. It's going to be rotated after a certain period of time. We want to make sure that you can't use the same password over and over again. I would suggest, even if you don't have IAM users in your account, set this up, okay? It literally takes 5 seconds. You can do it in the management console. You could write yourself a simple little Boto script if you wanted, right? Some sort of SDK. We use Python, so Boto. You could write something that just runs against the account and sets the password policy up. You're thinking, well, why would I care if I don't have IAM users? Well, mistakes happen sometimes. And somebody goes in and just says, I'm going to create a user because it's an easy way to do it. At least with the password policy in place, you're going to ensure that they don't make a password that's, 6 characters long and it's just password 123, right? You can kind of enforce some good password health. So I'd set this up regardless of what your plans are. One last piece, we use this all the time, easy to overlook again, is the credentials report. The credentials report, just like its name implies, is it gives us a list of all the users in our account and interesting information about those users, right? The last time they logged in, last time they used their console password, last time that password was rotated. Do they have access keys associated with their accounts? If they do, when were they created? How old are they? When were they last used? What service did they access? It also will give you some information about your root user, okay? The IAM Access Analyzer, the password policy, and the credential report, you'll find all of this if you're in the IAM console down the left-hand sidebar in that screen. You'll find all of these things here. You can run a credential report through the management console. You could write a script to do it, okay? This is kind of one of the starting points when we review an account for our customers. We run this credential report to give us a snapshot. It's kind of like, use an accounting analogy, it's a balance sheet. It's a point-in-time report of what users exist in this account. So those are all the key concepts, the things that, from my perspective, are really important for you to understand about IAM and how to approach IAM in a way that you can, improve the overall security of your AWS account. So we'll wrap up here with some general best practices. These are based off of sort of things that we've learned over the years on either helping people manage environments or reviewing environments on behalf of customers. And the first thing here is practice least privilege. Outside of old access keys or access keys that have never been used in a customer's account, I would say that overly permissive permissions documents are probably one of the biggest challenges that we see people run into, right? I'll make up a silly example. You got 10 IAM users in your account and 9 of them have administrative level access. I see why people do it because least privilege is hard. And this means that you're going to spend a time working with your customers, right? People, their applications, trying to figure out exactly what permissions are required for those folks to do their jobs, right? Whether it's a person, whether it's an application. So least privilege takes time. It takes patience. It takes understandings from all the parties that are involved. But it is one of the things that you absolutely should be doing in your environment. And one of the best ways to practice least privilege is don't forget about the IAM Access Analyzer. You can use that to help evaluate your policy documents and make sure they're still relevant. And you can just kind of always find opportunities to make those small incremental improvements and tighten up those permission statements. Oh, one other thing, practice is an important word here. This isn't, a lot of times what we see is somebody said, oh yeah, we did that. You're like, okay. What does that mean? Well, we created all the policies 3 years ago and they're least privilege. We've never looked at them since. This is an ongoing thing. It's not a one and done sort of situation. It's a practice. It's something that you iterate on over time. You make these small improvements to always just kind of keep tightening that stuff up. So don't think it's just sort of something you check off your list and you don't have to worry about it again. Monitoring is also really important, right? I was talking about this idea of everything in AWS is an API call. One of the things that we like to do is work with customers to identify what I generally call high value API calls. And from the IAM perspective, right? An example of a high value API call would be create access key, right? Somebody or something made an API call to create a new access key. To create a login profile. That's giving somebody the ability to log in through the management console. Creating a user. These are all API calls that we would strongly suggest that you monitor and you generate notifications, right? If you think about this idea of what's the phrase I'm looking for here? Oh man, it's funny. All of a sudden it just dropped out of my head. You've really got 2 different approaches to this. You've got preventative approach where we're going to say, you can't do that. You can never run that API call, or sort of more detective. That's the word I'm looking for. So we're going to detect that somebody or something created a user and we're going to go investigate it. So these are the kinds of things that you might want to take into consideration. And this monitoring idea applies to a lot more than just IAM. But you want to make sure that you identify those API calls that are important to you, that could be indications of things that you're not expecting in your account, and either block somebody or something from doing them in the first place, or generate notifications, Slack channel, email, ticket, however you want to handle it, to let somebody know that suddenly there's a new user in account A. Okay, so make sure you've got those monitors in place and that you're regularly auditing the API calls that are happening within, from an IAM perspective, to understand what's going on in your account. Humans. We've talked a lot about IAM users, right? I have an IAM user. Joe has an IAM user. In general, what we recommend is humans should use some type of federation. Okay? Under the hood, federation is going to use roles. So if I'm federating my users from somewhere else, an on-premise directory service that I've created a trust relationship with to AWS, I'm federating my users through something like AWS Identity Center, used to be called AWS SSO. What's happening there is I'm authenticating those users and I'm providing them with access to an account through role assumption. Okay? Way better way to provide human access to your environments. Easier to manage in the long run, also more secure. Our recommendation is the AWS Identity Center. It's a service that we use all the time as we're setting up new environments for customers, but it's kind of up to you to decide how you want to tackle that. But this goes back to the statement that I made earlier on. As best as you can, avoid users at all costs to improve your overall security, reduce that operational overhead. And the way that you avoid those users is to provide temporary access through role assumption instead, federation for users, for humans. Any applications that you deploy in your environment, EC2 based or otherwise, they should use temporary credentials. Again, role assumption is your friend here, right? I mentioned earlier on the sort of the second biggest problem that we see in a lot of accounts that we review for customers is overly permissive permission sets. The number one problem we run into are, I'm going to use the term ancient access keys, like thousands and thousands of days old. They've never been rotated. And in many cases, what we find is those very old access keys maybe have never even been used, okay? Depending on sort of what your policy was to set them up. If you combine really old or ancient access keys with overly permissive permission sets, that's hard to say, you can see how this could end up being a perfect storm, right? Those access keys leak out of the environment. You found yourself in this situation where everybody was an administrator. Now somebody has those access keys and they have administrative level access to your AWS account. So least privilege along with temporary access are two fantastic ways to improve the security of your account. Takes effort though. If you do find yourself in a situation with permanent credentials, whether those are console passwords, user IDs and login IDs and passwords, or access keys, okay? Make sure you have policies in place to force the rotation of those. The easiest way to force the rotation of a password, a user's password, is with a password policy. Unfortunately, access keys are a little tougher. So what we would generally suggest is have some sort of automation in place, right? 45 days, generate a notification out and say something like, this access key needs to be rotated. And you could sort of, over time, as you educate your users on how that policy is meant to be used, you could, deactivate keys after 60 days, deactivate keys after 90 days. But we've given you multiple warnings before we've done that. It can be a little destructive, but this is an opportunity to educate your users and help them understand why these policies and why you need to rotate those credentials, why it's so important. Okay, make sure you're rotating your credentials. Enforce the usage of MFA. MFA is probably one of the easiest things you can do in your account to improve the overall security, right? Something you know is your password, something you have is your token. And at an absolute minimum, you want to make sure that you have at least one multi-factor authentication device associated with the root user. Okay, at least one. I like multiples because it gives us a backup if something was to really go sideways on us. That's a minimum. And then what I would say is if any humans have user accounts within they're using IAM users, they also use MFA. And you can enforce the use of MFA through your policy documents. Avoid using the root user. We often see this in accounts where people just, old habits die hard. You didn't take it into consideration. You just log in with the root user and you do your thing. The problem with the root user is that if you're in a single account deployment, standalone AWS account deployment, you cannot control what that root user can do through policy. Now, if you're in an AWS organization deployment where you're using the organization service to help manage lots of AWS accounts, then you can control what the root user does. But in a standalone account, you cannot, okay? IAM policies do not apply. There's literally a handful of operations where the root user is required. For everything else, you should be using, ideally, federated user access, right? You're getting temporary access to your account through the AWS Identity Center, as an example. Only use the root user when absolutely required, and make sure that that root user has at least one MFA device associated with it to give us that additional layer of protection. Something you know is the password. It's a secure password stored in a secure location like a password vault. And then you've got an MFA key associated with it. Okay. Again, if you do find yourself in a situation where you have IAM users in your account, do not manage permissions at the individual user level. Instead, logically organize those users into groups and then assign permissions at the group level. The reason that this is important is kind of what I mentioned earlier on. The challenge that you're going to run into with IAM is, especially if you're creating individual users, is over time, the admin work goes up and to the right. The more users you add, the more time you're spending managing that. And if you're having to manage permissions at the individual user level, it increases the likelihood of a couple things happening, right? Well, actually, I should say this. It will absolutely increase the amount of time you're taking to manage that environment, but it also, the more management you're doing, the more users you have to manage, the more likely it is that at some point a mistake happens and somebody ends up with more permissions than they should. Okay. When you manage permissions at the group level, you reduce that operational overhead because now you're not managing individual permissions. And you also maybe reduce the likelihood of making those permissions errors because now you're not having to manage every individual user. Okay. Again, though, use a role first. Federate the access to your AWS account and let a role provide the credentials so you don't have to manage all of the users in the groups. You still have to manage the roles, remember that. And the last best practice here is take this idea of defense in depth. I know we've focused solely on IAM today. We talked about identity-based policies, but remember there's other types of policy documents. There's resource-based policies. There's permissions boundaries. There's service control policies, SCPs. So what we can do here is we can layer our defense. And what happens is IAM will evaluate all of the policies that are applicable to whatever that principal is asking to do, right, as a group. So now instead of just having one layer, identity policies, let's say I've got an application running on an EC2 instance, and it's trying to run, I don't know, a put object API call in S3. So what I have now is I have, I'm going to use a role assumption. Okay, so I've got the trust policy first to say, can this EC2 instance assume this role? Yes or no? There's my first line of defense. Then I have a permissions document that is practicing least privilege that says something like the action is allow on S3 put object on a particular S3 bucket. That bucket is defined through its ARN, its unique identifier. And then on the bucket side, I have a resource policy. So now I've got multiple layers of defense, multiple layers that the request has to go through and actually have a statement that says, yes, you're allowed to do this. Okay? So multiple layers of defense is always good. There's no sort of squishy center here. You got to get through all of those pieces, right? It's not just one layer of sort of, a wall, but if you could get past that wall, it's wide open. Okay. So that's it today, folks. I do have one last slide here. I thought it did not sync. That's too bad. But one of the things that we offer here, and I'll make sure when we publish this that we include this slide. I'm not sure why it didn't sync up, but we have a free IAM review that we do for customers. It involves a 1-hour phone call. We collect a bunch of data from your AWS account. We do that programmatically through a role assumption. Okay, we'll ask you to create roles for us. And we use that information to give you sort of a point-in-time report about the overall health of your IAM environment, completely free of charge. The deliverable at the end is a report where we're going to basically highlight things that if it were our account, we would address. And you can take that and go off and improve the security of your AWS account. So like I said, it's unfortunate that slide isn't here, but I'll make sure that I include it when we publish the slides later on. So thanks for joining us today, folks. I hope you learned some stuff here about how to improve IAM within your environment and use it to better secure your AWS accounts and the resources within those accounts. Enjoy the rest of your week, and we'll see you next time. Bye for now.